Last week's video was titled, "We are destroying the building management system industry." And the very first thing I said was, it started 10 years ago with energy management systems. In today's video, I wanted to expand slightly on that one component and discuss through what we typically do as building management systems when we build up these energy management systems, and more specifically around the visualization of all that data we've collected. And I'm pretty sure that most of you will realize in the first few minutes that what we're providing provides value to us to help us commission and service BMS systems, but essentially provides almost zero value to the end user. Let's run through a typical energy management system built up by a BMS company. And I say typical because some BMS engineers have a little bit more experience in this. However, my experience is that this is the average of what normally is done. So our very first graphic that we open up, our home page, which really has this sort of picture in the middle of the building, which I think is a waste of space, but we have them on most projects. And then in our header up top here, we have chill water temperature, hot water temperature, fire alarm, and some outside air, weather conditions, client's logo, and the name of the site. What we typically have is we have some buttons that link to all the main systems. For example, the chiller management system, heating hot water system, air handling units, hydraulics, lifts, generators, fire, for example. And then on the right-hand side, sometimes we have all these buttons that link up to all of the 30 levels. So you're going to do some monitoring or investigations or some diagnosis on level 10, you click level 10's button and off you go to the floor plan, and you can navigate through the VAVs or the chill beams and package units and all those sorts of things. There's usually a button on here called meter, or energy management system, or something like that. So the operator would come to the home page and click on metering. Now once the operator clicked on that meter button, it goes off to the second page, and the second BMS graphic page is called metering. And on that page we have some more buttons that link to other more detailed metering pages. So for example, main switchboard 1, main switchboard 2. In Australia we call these mechanical services switchboards. In other countries they're called motor control centers or motor control panels. You can click on here and get to all the electric meters for the lifts. There's a button here called low-rise floors and high-rise floors. So from here the operator can link to other graphics with more information about the electric meters for those systems or those zones or floors. Now let's assume we click on the low rise floors button. Now once you've clicked through to the low rise floors BMS graphic for metering, there's normally buttons for each of the floors. So let's say for example the operator wants to go and look at the power consumption for lighting and power on level 8. They would click on the button for level 8, and then the graphic would open to provide the information, the more detailed metering information for level 8. When the operator opened up the level 8 graphic, we were then presented with little modules or little dashboards of the data that we're pulling out of each of the electric meters. So for example, here we have tenant, the first tenant, lighting, tenant 1, power, tenant 2, lighting, tenant 2, power. So for level 8, for the tenant, and there'd be other meters associated to the landlord's power and the landlord's lighting on level 8. But here we have 4 electric meters, 2 lighting meters, 2 power meters. And displayed on this is voltage 123, current 123 kilowatts, and this particular meter, tenant 1 lighting, has 227,325 kilowatt hours. This is the important thing, the power consumption for that electric meter. So the main point I'm trying to make here is that the operator first goes to the home page, clicks on the electric meter or the energy management system. Then they've got to go to a second page for metering and choose the area they want to go to. And then they go to the next area, they pick the floor, and eventually they end up over here. So that was 4 pages we went through to get to here, and the information that's presented here is the power consumption for those meters. Now keep in mind that there's 200 electric meters spread across, let's say, 50 different graphic pages. So let's run through the general process on a new construction project. We've got 200 electric meters. So the BMS design engineer does the design, creates all the meter schedules, and does all the network drawing design. That enables the BMS installer to now run the RS485 subnetworks up the electrical risers to all the lighting and power boards on the floors, through the plant rooms to all the mechanical boards, and into the main electrical switch rooms for main switchboard 1, main switchboard 2. So the installation all happens for months and months and months. Then the BMS software engineer builds the database for 200 electric meters, does all the graphics, 50 pages, does all the binding, gets that done. Then it goes to site, we download everything. The BMS commissioning technician addresses the electric meter, gets the points online into the BMS, and then checks through the commissioning process, filling in the meter validation sheets, that the BMS is reading the exact same values as what is being displayed on the electric meters. And then right at the end, after 6 months of hard work, the consultant comes to site to do the witnessing, and we check that the BMS readings tie up with the readings on the electric meters. And we'll do a sample check of 10 or 20% of the electric meters. Some electric meters in the lighting power boards, some in the switch rooms, some on the mechanical boards, a few different checks of the different types of electric meters that might be installed on site. We sign off, we all do high-fives, and we celebrate the project. Then the BMS service department for the next 15 years maintains all that, replaces a few faulty gateways, fixes up some broken cables, keeps the thing working, checks that they're all reading properly. Now, that process and what's been provided is excellent for commissioning, witnessing, and service. But does that really provide any value to the end user? People who are trying to diagnose energy consumption and are trying to achieve 5-star energy efficiency ratings, sustainability engineers, energy efficiency people. That information provides no value to them. 200 meters scattered across 50 graphics pages provides zero value to anybody, because that doesn't tell you how much power we're using on fans, on pumps, the complete chill water system, all the tenants' lighting, all the tenants' power, the complete consumption of all the lifts. That doesn't tell us any of that. And I would almost exaggerate the point and say that 200 meters buried across 50 pages of graphics, we shouldn't even have provided the metering at all. The whole thing was a waste of time. That whole visualization of information is only useful to us to help us commission the meters, witness and sign off the meters, and maintain the meters. That method does not allow us to fine-tune the building, to study where power is being used, where we're using too much power consumption. Okay, so how can we improve on this? The very first thing we have to do is to create virtual meters, because 200 meters buried in a BMS doesn't provide any value. A virtual meter is a software meter where you add up or subtract other meters to create this sort of totalized power consumption of a system. So the most common one is the chill water system. So you create a virtual meter called chill water system, and you add up all the electric meters associated to the chillers, the pumps, and the cooling tower fans. Now it usually isn't quite as simple as that, because the mechanical board's chassis may not have been broken down to separate miscellaneous equipment from the chill water system equipment. So what you do is your virtual meter would add the 3 electric meters from the 3 chillers, and then you'd go and get the kilowatt hours out of each variable speed drive through the high level interface. So this formula for the virtual meter for the chilled system has 3 electric meters and a whole bunch of kilowatt hours VSD HLRs for the chilled pumps, the condensed water pumps, and the cooling tower fans. So that's your first example of a virtual meter. You could also create a virtual meter for the car park ventilation system. So that virtual meter adds up all the electrical power consumption from the exhaust fans and the supply makeup air fans. That one virtual meter is actually really useful to understand how much power the car park system is using. Then for the high-rise plant room, which serves all the air conditioning for say 10 or 15 floors, where we have perhaps our 4 perimeter air handling units and our 2 internal air handling units. So there's 6 supply fans, and you could have say 6 return fans, maybe 2 toilet exhaust fans, maybe an outside air makeup fan for package units or supplementary cooling. So that virtual meter called high-rise plant room adds up all that power consumption, and the same for the low-rise plant room. And then you could have 2 or 3 electric meters summed together for the power consumption for all the lifts. And then, as I sort of touched on before, I think you could have a virtual meter called tenant lighting, tenant power, landlord lighting, landlord power. So what happens now is when you click on that button for the metering system from the main page, it comes to this other energy management system homepage with say 6 to 10 virtual meters populated on there. And now you can see on that one page the daily or the weekly or the monthly power consumption for the chilled system, you know, the high-rise plant room, the low-rise plant room, all these other different sorts of things. That provides really good value to somebody, because if you're looking at that, you could straight away see, hey, like, why is the low-rise plant room using 30% more fan power than the high-rise plant room? What's going on there? Go and check it out. And from there, you could then further diagnose this additional power consumption by drilling down into these commissioning graphics that we usually create, going down into individual metering graphics. The second thing we could do is to expand on that. It would be really impressive if you built the virtual meters to line up with the energy model categories. So with these high-grade, high-performing, very expensive commercial offices, sometimes there's some sort of a sustainability engineer that does an energy model for the building and says, okay, if we buy these type of chillers and we have these type of pumps and the occupancy hours are these hours and insulation stuff and all sorts of things that we've got no idea about, they will calculate that this building will achieve a 5-star energy efficiency rating. That's the energy model. That's how we know how efficient our chillers have to be, the ones we purchase, to achieve this end goal, that after 12 months of intensive tuning, we actually do achieve the 5-star energy efficiency rating. So that consultant, the energy efficiency consultant or the sustainability consultant, would have broken up all these categories: chilled water, fans, pumps, lifts, whatever that is. So you send an RFI, request for information, at the start of the job. Please, can we have a meeting with the sustainability engineer to work out, because it's normally a bit complicated, but sometimes they can take the energy model and they can sort of break it down into bigger categories that make sense for how we monitor equipment. That's extremely useful, because now in the first 12 months of our tuning phase, we know exactly how much power through the seasons, summer and winter, our chilled system should be using as per the energy model. That would be incredibly valuable, because you've almost got no chance of not achieving the energy efficiency rating. When you have 200 electric meters buried into 50 pages with no virtual meters, you've got almost no way to guarantee that your tuning efforts will end up achieving the 5-star energy efficiency rating. Because you could easily have the energy efficiency assessor after 12 months come and assess the building. They go to the utility bills, electric, gas, water. They do the thing, the net lettable area of the floor, all that stuff. And they might calculate that you got a 4.5-star energy efficiency rating. You didn't get the 5-star because we never had the tools in our energy management system to enable us to guarantee that through our tuning phase. The next thing to do, which is a little bit more difficult, is start to calculate COP, coefficient of performance. Now, it's quite common that we would monitor through the high-level interface the COP of the chiller. So this chiller, in isolation of the rest of the plant, has a particular COP rating, coefficient of performance. But what we don't do is to calculate the COP of the entire chiller system. So we already have our virtual meter called chiller system power consumption. If we then take that and we calculate the kilowatts of refrigerant power that each chiller runs, so we've got 3 chillers running at 800 kilowatts of refrigerant each. With the electrical power, we can calculate the entire chiller plant's COP, coefficient of performance. Because at the moment, all of us are focused on making the chillers most efficient as possible. So we will reduce the condenser water temperature and we will increase the chiller supply water temperature. And this chiller, the running chiller, its COP will go up. We'll all be doing high fives. What we don't realize is that the cooling tower fans are running harder and the pumps are running harder. We might have low delta T type problems, maybe. So when you have the entire chiller system COP, that's a very useful tool in tuning. So as we're doing our energy efficiency tuning, we can see that as we make these different changes, yes, the chiller's getting better, but how's that impacting on the whole plant? So although COP isn't necessarily a thing around an energy management system, it is still a useful thing that should be put in that thought process. So imagine how amazing it would be if you opened up the chiller graphic, and in the chiller graphic, a little schematic of the chillers and the pumps and the bypass and all that sort of thing. On that graphic, we had a little widget there, or a little dashboard thing showing us the COP of the entire plant, and we had a little link there straight to our virtual meter for the chiller system, meaning don't even go into the energy management system. Use that machine to do the work and then build those virtual meters back into our graphics. That's a major advantage that we have over third-party energy management systems because they probably can't embed their virtual meters into our graphics. So there's a great way that BMS companies can actually provide more value, maybe, than third-party energy management systems. Another point is when you click through the energy management system and you come to, for example, MSB1, main switchboard 1, you open that graphic, don't just put a table on there of all the electric meters on that board, 15, 20 meters. Get the electrical single line diagrams and import them into the graphic so we can see the flow of power from the main switchboard, the incoming power of the street, the generator, whatever it is, how that power flows. And then bind onto that single line diagram the kilowatts, the instantaneous kilowatt value. So when you open that, you can see your main incoming power value, not kilowatt hours, kilowatts, instantaneous kilowatts, and how that sort of flows through to the mechanical boards and et cetera, et cetera. Like that's really useful for diagnosing issues. And then create some virtual meters. Add up these 3 meters and subtract those 2 meters. There's a virtual meter. It's a virtual meter that where a real meter doesn't exist. That is value. 200 meters buried across 50 graphics pages does not provide any value. So there should not be a market for third-party energy management systems. There shouldn't be a market for them. We should just close this thing out in our construction phase. When you've spent all this time, doing the design for the metering system and all the engineering and all the graphics and all the binding and all the commissioning, you spend all that time doing this, just spend another 40 hours on the end there and create a whole bunch of virtual meters and have a home page that the operators can look at. Yep, that's good, that's good, good. And then if there's a problem, they can dive deeper down into these commissioning type graphics to try and find out that exact meter, what's going on there. Guys, next week, send your boss an email and say to him, hey, let's arrange a virtual meeting with the team, your company, and let's workshop how we can improve our visualization of energy management systems. We can make a difference. See you next week. Last week's video was titled, We Are Destroying the building management system. Jeez, like it. All the engineering, design, commissioning, witnessing, all that effort, and we deliver that. I don't think I should say all that. In today's video, we are going to, that's not what we're supposed to be saying. What we as BMS companies, how we present all the data, the visualization that we've collected.